be able to see the presentation for today. So thank you. As mentioned before, the purpose of today's webinar is to discuss the latest enhancements for container security in Microsoft Defender for Cloud. So this is really covering an array of updates that we've released up until this point. So if you're not familiar with Microsoft Defender for Cloud, essentially here Microsoft provides comprehensive code to runtime security, and this all starts with secure development, which includes native security controls infused in the existing developer workflows to help you code and build applications securely. And Defender for Cloud includes an array of capabilities such as contextual security posture, which will help you prioritize and reduce risk continuously across the entire cloud application lifecycle. It also helps you protect your cloud environment against evolving threats with near real-time detections for cloud workloads, data and APIs, and also includes a unified XDR experience as well, which you can see by this image. And we support the three major cloud environments here: Azure, AWS, and GCP, in order to provide you code to cloud runtime security. So the focus for today, as mentioned, is on the container security capabilities. And in Defender for Cloud, we provide, we're looking at different container security needs of all the stakeholders here. So first, as you can see, visibility, context, and risk. So our goal here is to show you the entire Kubernetes estate, so providing you visibility into the Kubernetes control plane and data plane, looking at different components such as images, pods, deployments, etc., that exist within your Kubernetes estate, and also show you the security context of those Kubernetes assets as well. And in addition to this, help you apply policy consistently across the entire estate. The next security persona that we address is also the DevSecOps. So making sure that your containerized workloads are secure from the get-go, and integrate container security controls seamlessly and effectively from code to cloud. And then in addition to that, we also support cloud native posture. So making sure that your container images remain secure across the software development lifecycle, and that they're compliant with regulatory standards and industry best practices. And then finally, we also look at runtime threat protection needs. So alerting you when there's a possible attack within your Kubernetes environment, and providing you with the tools and resources needed for investigation and mitigation. So with all this in mind, the capabilities that we will be discussing today fit into these different container security needs for these different stakeholders. Okay, and here we have an overview of what we'll be discussing today. So as I mentioned from the previous slide, we're looking at different capabilities here, from providing you more visibility into your Kubernetes estate, to also providing you with additional capabilities for securing the software supply chain, such as supporting third-party registries. And then you'll also see here we've added additional capabilities for runtime threat detection as well that we'll cover in the later half of the presentation. So with all that in mind, we'll get started here in showing you what's new. So essentially, we'll explain each of these capabilities and show you how you can leverage them within the Defender for Cloud portal. So first off, we want to discuss how we've integrated the Kubernetes authorization data into Defender for Cloud's security graph. If you're not familiar with Kubernetes RBAC, so RBAC is essentially role-based access control, And it's a way to manage access to resources within the Kubernetes API. And this is actually based on roles assigned to users or service accounts. And it uses fine-grained controls on what actions can be performed on which resources. And the key security value here is that it's Kubernetes RBAC allows you to limit access to Kubernetes resources based on the role that the user can hold. And essentially, it's helping you to ensure that the users and applications have the appropriate permissions that they need within the cluster and only have access to the resources that they need within the cluster as well. And roles can be binded to different entities such as users. So this could be individual humans that need access to the Kubernetes resources, or it could also be Azure Active Directory users. Some examples that you can consider are developers or cluster admins. There can also be groups as well, which is essentially just a collection of users. And it's useful in this case for assigning the same permissions to multiple people at the same time. So for example, you could have a group called a dev team, which includes all members of the dev team that need specific roles to deploy and manage their applications. And then you can also have roles for service accounts. And a service account is a special type of account that's used by applications running in the cluster. So this could be used for internal cluster communication or external cluster communication. And some possible attack flows here that involve the RBAC, Kubernetes RBAC, include cloud to cluster. So this is looking at how an attacker could use another cloud resource to gain access to the cluster. There's also inter-cluster attack flows as well, and this is essentially connecting. This is allowing the attacker to connect to the cluster and exploit cluster resources. So for example, an attacker can manage one issue within the cluster and then move on to another resource within the cluster as well. And then finally, we have cluster to cloud attack paths where an attacker can utilize permissions on the cloud resources, or they can utilize permissions on the cluster resources to gain access to cloud resources. So taking a look at examples of what this could look like. So here we have a role, which is defining permissions for a specific namespace. So what actions can be performed on resources in that namespace. And then here we can see the role binding, which is tying the user here, the developer, to the rules for that namespace. So here in our default namespace, we have a developer who's binded to this developer role that includes capabilities such as being able to list the pods, get the pods, create pods, and delete pods. And you can see here that these permissions are bounded by this namespace through the blue outline that's included here. Another example that you could see is a cluster and cluster role binding. So the difference here is that this cluster role, it is similar to a role, but here it applies to the entire cluster rather than just a single namespace. So in the previous slide, we saw that we were bounded by that default namespace, but that's no longer the case with this cluster role and cluster role binding. So I have my cluster admin here who has this cluster admin role, and that allows them permissions to view the nodes on the cluster, delete nodes, and create nodes. Now, with all of this in mind, we can discuss more about how we've included this within Defender for Cloud. So as part of the latest updates to agentless container posture, we've expanded our discovery of the Kubernetes cluster to include Kubernetes identity and access information. And with this information, customers can now use the Cloud Security Explorer to query entities such as the Kubernetes service accounts and their associated permissions, impersonation capabilities, and also permissions associated with the Kubernetes workloads via the service accounts. And this Kubernetes identity and access information is also being used to expose new attack methods, which is enriched with our attack paths. So you'll see that this information is also included in the attack paths as well. And the key thing here is that unlike the cloud identity and access information, the Kubernetes identity and access information is not really easily accessible to security practitioners. But now through these updates that we've added, they can use capabilities such as the Cloud Security Explorer to get all the information they need for their estate. So you'll see here that this is available across multi-cloud, and you can get access to these capabilities with Defender CSPM or Defender for Containers. And with either plan, you get access to the Cloud Security Explorer, but to specifically see the attack paths, this would require the Defender CSPM capability. So speaking of attack paths, we've also updated the engine that we're using to surface the attack paths. So first off, last year, we released a new attack path analysis engine. And what we've done here is extended that engine to also support container use cases. So organizations that are using Defender CSPM can now leverage this new attack path analysis engine to detect more complex and sophisticated attack patterns that attackers can use to breach their containerized environments. So now that we've discussed the added RBAC data and the attack paths, let's jump into the Azure portal and see what all of this looks like in the portal. So first off, one of the things that I mentioned was the RBAC data and the attack paths. So you'll see here that we're able to generate more attack paths for our container workloads. And we can start with this example here, which is an attack path that has a high risk level. And it's looking at an internet exposed container with high severity vulnerabilities that allows for lateral movement to a critical Kubernetes cluster. So first off, with this update, you can see here that we've added an attack story, which is essentially explaining how an attacker could leverage this attack path here. So you see first off, the attacker can exploit vulnerabilities via the internet exposure. And we see in the attack flow how the container is exposed to the internet. And then one of the things that you'll see here that's been added is that we're able to show that this container can authenticate as this service account, which has permissions to this critical Kubernetes cluster. And we've defined criticality of this cluster, which is something that will be discussed later on in the presentation. But first off, with the enhancements here, we have a pod, which is showing this light bulb. And then in the insights here, it's telling us that it's exposed to the internet and uses host network. And we've added more insights here that actually show you the exposure rule for this pod. So it shows you the port ranges and the destination port ranges as well. And then we see our container, which is also using host network, and it's exposed to the internet. And again, here you see the exposure rule for the container. And as we mentioned before with the Kubernetes RBAC, we can see that this container can actually authenticate as this service account. and we see some information about this default service account here. And we see that this service account actually has permissions to the Kubernetes cluster. So this is one example of the improved attack paths that we're providing, as well as how we're integrating the Kubernetes RBAC data. Another example can be seen in the Cloud Security Explorer. So already here, we can see that in the identity and access, you have the option to select the Kubernetes service account. And then from there, you would be able to see all service accounts that exist in the environment. But here I've added the condition that this service account has permission to other resources, such as the cluster and the namespace. You could also do other conditions, such as being able to impersonate as. But in my search here, I see service accounts that meet the conditions here. So here I have an admin service account that has permissions to my Kubernetes cluster. And earlier we talked about roles and role bindings. So I'm actually able to see that information here. I see the cluster admin and so the role name and then the role binding as well. And I also see the permissions of this service account. So here it shows that the service account basically has all permissions from the asterisks that are being shown here. So Cloud Security Explorer is another way that you can query that information. So previously we just looked at the service accounts, but you can actually look at the workload level as well. So we see that the Kubernetes workload in this search can authenticate as, which was one of the conditions that we saw previously. And here we selected an application identity, which has permissions to, and went ahead and selected everything here. But in these outcomes, you can see that the pod here can authenticate as this service account, which has connections to the different resource types that we mentioned, or that we included here in the search. Now, that was a look at the RBAC data, and as we saw in the attack paths as well, we also saw the information on intranet exposure, which is also included in the Cloud Security Explorer. So we've added additional enrichments for Kubernetes networking. So you'll see here in that containers, you can select the services or ingresses for networking. In my search here, I'm showing how you can see which Kubernetes entities are exposed to the intranet, and then you can also add additional parameters, such as in this case, if it's able to get traffic from where it's able to get traffic from, but you could also see if it uses host network as well. But in this case, I'm seeing that these different entities are exposed to the internet, and they get traffic to service ports. And here I've even gone a step further to specify that service port as well, which is shown in the results. Now, another thing that we've released recently for container security is the support for Docker Hub registries. And essentially here, the motivation was that, one, we acknowledge that organizations are using external registries. So currently we support all major cloud registries for AWS, Azure, and GCP. But we acknowledge that customers are using additional third-party registries like Docker Hub. And also Docker Hub is one of the most popular container registries and extensively used by our customers. So for that, we've added support in Defender for Cloud. and you can enjoy the same built-in capabilities that you see for other cloud registries as well. And this process involves creating a connector for the Docker Hub registry that we'll see here in a minute. But essentially, there's different plans that you can turn on for the connector. So with foundational CSPM, you're able to discover the registry and get inventory into the images. With the Defender for Containers plan, you're also able to get the vulnerability scanning for those images in Docker Hub, as well as apply any regulatory compliance standards as well. And then with Defender CSPM, you also get additional Defender CSPM capabilities, which include the attack paths, the internet exposure analysis, governance rules, custom recommendations, etc. So taking a look at the portal here. Okay, so in this environment settings blade, you see the option to add a Docker Hub registry, and you'll actually notice that, once you create the connector name, you can configure a scan interval. So this would be the interval for when we're scanning that Docker Hub registry to detect and scan new images for vulnerabilities. And then once you've entered those details, you also have the option to select the different plans that we looked at. So you'll see the option to select the foundational CSPM, Defender CSPM, and the Defender for Containers plan. So after you've done this, and then you've configured access by inputting the access token on the next screen, you'll actually see those Docker Hub container images show up here in inventory. And we can see that, so this is my image that's been onboarded from Docker Hub. And we actually see that there's an existing recommendation for this image, and we're using the same Microsoft Defender vulnerability scanner as well. So you're getting consistent results for the images that are stored in Docker Hub. So taking a look at the next capability here. So in addition to all the things that we discussed, we've also added other upgrades to the cloud security graph. The first one of that is expanding our discovery of container images to include all images discovered by Defender for Cloud, not just images that have vulnerability assessments. And we've also added metadata to query these images and for more for more detailed information with the Cloud Security Explorer. And then on top of discovering the container images, we've also added a software inventory in the Cloud Security Explorer as well. And we're using the Defender Vulnerability Management Scanner to generate this software list, which means that only the scanned images will have a software inventory. And before we take a look at what this looks like in the Cloud Security Explorer, this is an idea of some of the new data that we've added for registry images. So this is available for all images, even those that don't have recommendations. And then taking a closer look here at the portal. Okay. So here we can, I've already gone ahead and searched for container images. As you can see, it shows us all the images here in my environment. And this is a part of the agentless discovery of Kubernetes capability. So I'm even able to see, so not just Docker Hub images, but I have images here that are running from GitHub container registries as well. It also shows me those images from Microsoft container registries. If I wanted to further specify what kinds of images that I want to see here. I could create a parameter here for cloud provider. So if I only wanted to see Azure images, it would show me that. I can also add more metadata as well. So that includes tags, OS digest, etc. And one thing that I could do here, for example, if I wanted to see container images by the latest tag, I could filter by that, and it shows me each image that has the tag latest. And then, as I mentioned before, we've also added the has installed software capability. So this is really helpful for cases where we detect where there's a software that's been impacted by a zero-day vulnerability, which may not be detected by the scanner yet. So if I know that software, I can use this query. So it says container images that has installed software, and I can specify, for example, the vendor, and let's say it contains, and then I'll type in Alpine as an example. Okay, and it shows me all these images that have installed software, so we see the full list of installed software, and it's showing me all the results where vendor name contains Alpine, which we can see here with this example. And then the last thing that I want to cover here as part of these posture updates are some updates that we made in terms of how we're showing the risk-based recommendation for runtime scanning. So as part of the latest updates to agentless container posture, we're changing we've updated the modeling that we're using for Kubernetes workloads. And rather than reflecting each runtime instance in the graph, we're now providing visibility that's based on the workload configuration deployed to Kubernetes. And this allows us to avoid reporting identical Kubernetes objects that are part of the same workload, and also allows us to avoid any outdated information that could be due to fluctuations caused by the refresh rate of the security graph versus the refresh rate at of the actual runtime environment. And this change is affected in two ways. The first here is for the risk-based recommendations. So rather than creating a report for example, every single pod in a replica set, we're just creating a report for one pod within that replica set, because essentially they would be, copies of the same pod. And with this, we've actually updated the recommendation IDs for the risk-based recommendations for vulnerability findings. So here, this table shows the old assessment ID, and now we've added the new assessment ID as well. And this is also included in the documentation for you to reference. And if we go to back to the Defender portal, we can see those changes implemented. So first off, with this modeling update, you can see here for these recommendations report on vulnerable containers running in the cluster, and it shows me the namespace, the pod, and you'll notice an asterisk here. So this is instead of showing me every single instance of this pod, I'm just getting one report, which would reflect on, rather than showing me every instance of the pod, I just see one instance of that in the report here, which is helpful in reducing noise. And then we see this change here with the asterisk, and We actually saw it before in the clouds, in the attack paths as well. So we see that this pod here again has the asterisk. So instead of showing every instance of this pod, we just show you one instance. And to take a closer look at it here, in the Cloud Security Explorer, I've gone ahead and searched for Kubernetes workloads and containers that exist in this environment. And you can see here I get different results and resource types. So for example, I have this deployment here for AMA logs. And these are actually two different deployments, even though they have the same name. But they include this replica set here. And as part of the replica set, it's deploying several pods. But instead of showing me every pod in that replica set, I'm only viewing one, which is again represented by the asterisk. And then we have also the containers that are part of that deployment as well. And when we go to view the resource details, we can actually see the pod name for that container. Now, with all this in mind, that was a look at the more the posture and visibility capabilities that we added. Now I'm going to hand it over to Vasavi to walk us through the threat protection capabilities.
Yeah, thank you, Future, for walking through the features on the latest features for all the CSPM. So let me walk you through the features for the runtime threat detection as well and in the container space. So here comes some of the features, like I hope I'm audible and my screen is shared.
Yep, we can see and hear you.
Yeah, thank you. So here we can see the binary drift detection is the feature that we have recently introduced in the runtime threat detection space for containers. So let me walk you through that. Okay, so binary drift detection feature is now generally available. So let me walk you through what exactly is binary drift. So container binary drift is when, let's say, someone runs an executable inside the running container that was not part of the original image. So this can be sometimes intentional or it can indicate an attack. So when I say intentional, the drift can happen because your administrators are changing an application, say in production, or they are trying to download new packages and install some IT tools for local maintenance. But there can be also a threat situation where drift can happen. Like say an attacker who gained access to your environment can make configuration modifications or elevated privileges for users. Or the attacker can go ahead and disable the security monitoring tools. So how can you detect such drift and be aware of what's happening in your running containers? So you can use a binary drift detection feature to alert you when there is a difference between the running workload in the container and the original image. So Defender for Containers has a binary drift detection feature that's available for Azure AKS, Amazon EKS, and Google GKE clusters as well. So if you look at the prerequisites to use binary drift detection, you need to enable Defender for Containers plan, and also Defender for Containers sensor must be enabled on the subscriptions and connectors. So I will walk you through this process in the demo. And you need to create drift policies. So please be noted that drift policies are different from Azure policies. We heard some customers ask this question, so just clarifying on this. So to create drift policies, you need security admin or higher permissions on the tenant. And to view drift policies, you will need a security reader or higher permissions on the tenant. So here are some resources referring to the binary drift detection. So let me walk you through the demo. So here comes, let me select on the Defender for Cloud portal. We need to see to
Vasavi,
that.
we can't see your screen.
Sorry, let me share it. I hope you can see my screen now.
We can see it. Oh,
thank you for confirming. Yeah. So here you can see as we need to see to that the prerequisites are met. First, I need to enable Defender for Containers plan on my Azure subscription or AWS connector or the GCP connector. So I will pick my Azure subscription here and see to that Defender for Containers plan is enabled. And so here I'm saying to that the Defender for Containers plan is enabled. And the next prerequisite is I need to enable the Defender sensor. So for that, I will go ahead and go to my settings and enable Defender sensor extension so that auto provisioning of sensor is configured for all my AKS resources. Save the settings and continue. So once this is done, the next step is to configure the drift policy. So let me go ahead and configure the drift policy here. So go back to the Defender for Cloud portal, and under environment settings, you can see the containers drift policy. So here we can see the default rules. So here you can see the last two rules are default rules, default binary drift rule. So the default drift rule says ignore the drift detection is the action configured for by default, which means the policy detects the drift, but it just ignores the drift. I can change it to drift detection alert, which I want to receive an alert whenever there is a drift detected. Also, you can see the cloud scope here by default is Azure, AWS and GCP. So please remember that we should have met the prerequisites like Defender for Containers plan and Defender sensor enabled on all Azure subscriptions, AWS connectors and GCP connectors. And this is the default rule. And the next default rule that you can see here is alert on kube system namespace. So let me show what this looks like. So the default action here you can see is drift detection alert, which means alert will be triggered whenever there is a drift on the kube system namespace, because kube system namespace is the system namespace, and all the services or service accounts inside this kube system namespace has high privilege permissions. And so I want to receive an alert whenever there is a drift detected in this namespace. So I will go ahead and configure a alert whenever there is a drift detected on this namespace. So these two are the default rules that are predefined within your environment. On top of it, you can also create your own rules. So let me go ahead and create a new drift detection alert called drift on production. Say I want to detect any drift on my production environment. So here I'm creating a rule name called drift on production. And here I want to get alert on for any of the drift that is detected on my production systems. And here in the scope, I select all my Azure subscriptions. So say I give it a scope name, and the cloud scope, I select my all my Azure subscriptions, and the resource scope, I can select here, say all the pod names or all the pod labels with the key name where the environment is equal to production. So let me go ahead and configure this policy, save this policy, and you can also see allow list for processes here. So the intention of having this is, say, if I want to exclude any processes like monitoring agents, logging agents to be exempt from my drift detection, to avoid any false positives, I can configure them as well. I'll go ahead and apply this here. Click on save so that my rule is applied to my environment, Azure environment. Here we can also see the priority assigned to each rule. So what does this mean is rules are evaluated in ascending order of priority. So the first rule is evaluated. If it is not a match, it goes to the next rule. If none of the rules match, then it goes to the default binary drift rule. So going back, so how this works within your environment, uh, the alert shows here. You can see how now that we configured all the prerequisites and a binary drift rule, whenever there is a drift on my production pods, sensor should detect the drift and trigger an alert. So let me show the alert here. So here is the alert. The alert shows the affected resource, and we can also see the MITRE attack tactic that is used here, that is the execution, and the suspicious process that initiated this alert. So we can also see the host within the cluster, the node pool where this container is running, and also the original image this pod was deployed. And all these details are available in the alert. Also, under take action, you can also open the logs and see the operations performed in the similar time frame. So here I can see the operations performed, like the list cluster admin credential. So this can be a suspicious activity on my cluster and in the same time frame. So I want to go ahead and investigate more about this. So we can go through all this process. I think this will be helpful for the SOC teams to detect drift on time and also investigate more in the with the relevant events that are happened. Okay, let me go back to the slide and talk about the next feature, that is criticality classification for Kubernetes assets. So here comes the criticality classification feature. So Defender for Cloud has the capability to identify and tag your business critical resources. This empowers our customers to explicitly identify their most critical assets, ensuring risk prioritization for most critical resources. And when you tag your resources as critical in the background, what happens is it uses the critical assets engine created by Microsoft Security Exposure Management, and customers should be able to tag any critical Kubernetes resources based on resource names, Kubernetes labels, or Kubernetes namespaces, etc. So the prerequisites to enable this feature is you should have Defender CSPM plan enabled. And to create the classification rules, you need security operator or higher permissions. And to read the classification rules, you will need the global reader and security reader permissions. Also, you need access to the XDR portal. So here are the links to the how to configure the critical assets protection. I will walk you through the demo here. Let me take you to the demo. So here comes, the settings. You can see, sorry, let me go back. So here comes within the Defender for Cloud portal under environment settings. You can click on the resource criticality tab, and here under critical asset management, uh, I can click on Microsoft Defender portal. So here, when you click on this, it will take you to the XDR portal. And here you can see or under exposure management, you can under the overview, you can actually go to this critical asset management. So here I can create a new classification for my resources. So say, go ahead, create a new classification. Say I give it a name called prod Kubernetes and give it a description and click on the cloud resource. So the cloud resource can be here. You can select the filter, and I can tag my resources based on Kubernetes labels, Kubernetes namespaces, resource name, resource tags, or resource type category. So let me say I want to select my based on the Kubernetes namespace equals, say, cube system, and say apply. Or I can add more filters here. So I can also tag my resources based on the resource type category here equals for all my Kubernetes clusters. And say apply here. And so let me keep it simple. Let me configure just one rule. So here you can see all the preview under preview assets. We can see all the Kubernetes clusters within my environment that I have selected, and you can assign the criticality level. So here the criticality level can be very high, medium, low. So I can go ahead and assign the criticality level as very high and submit this rule to my exposure management system. So once this is done, I think you can also go back to your Azure Defender for Cloud portal. And here under inventory, you can also see the resources that are tagged as critical resources once you have tagged your resources in the exposure management system. So here, all the critical resources that you have tagged will appear in the inventory as critical assets. So the critical assets also, and also you can see the recommendations. So you can also see the recommendations page. You can see all the recommendations which are prioritized based on the asset criticality. Here you can see the critical resource tag is attached to the recommendation as well. And also you can go to the attack path analysis, and you can also identify the attack paths that are identified with the critical resources as well here. So here, all your critical resource attack paths can be prioritized, or the recommendations can be prioritized. And also, even in the Security Explorer, you can see your Kubernetes clusters, say, with go to metadata, and it has the criticality level configured as the resource criticality level as, say, very high business criticality, and search within your environment. And you can see the Kubernetes clusters with very high criticality level are all tagged here. If you go to view details, you can also see the insights as criticality level, and you can prioritize fixing the any of your recommendations, and your fixing your attack paths for your critical resources from this stack. Okay, let us go back to the next feature, that is the threat analytics report that is available for containers incidents in XDR. So what is added here within the XDR portal is there is a new analytics report for container incidents in XDR is available as an educational material for the SOC analyst, where they can investigate a container related threat. So we see most SOC teams are not experts in containerized environments, and this analytic report helps educate them about the threats and guide them how to effectively respond to the malicious activities by adding the container and Kubernetes specific context. So coming to the prerequisites to detect the real-time threats, customers need to enable Defender for Containers plan, and the Defender for, sensor also should be enabled. And they also need the access to the Defender XDR portal, and you can see some relevant links attached here to learn more about this threat analytics report. So let me go to the demo again. So here in the portal, in the threat analytics report, under threat intelligence, in the XDR portal, under threat intelligence report, under threat analytics, we can see a lot of threat analytics reports are available. I can filter based on the threat tags or the report type. And also I have just filtered based on the container threat reports here. So here you can see the technique profile that is through the container attacks that we can look into. So what is added here, the analyst report, we can also see the full report here and under the analyst report. And this analyst report shows about all the techniques, overview. Even a beginner with little container knowledge also can understand about the Kubernetes threats and the prevention measures to follow. How this what are the prevention methods that needs to be added here. And we can also see the threat matrix. The analytics report also gives you the threat matrix that is associated with the Kubernetes attacks. So here, the analytics report contains threats using Kubernetes threat matrix and includes hunting queries as well. Here, if you come down, we can also see some hunting queries. So these are pre-built in queries that the SOC analyst can go ahead and use the built-in or predefined queries to hunt further within the XDR portal. The good part is whenever there is an incident that is available within the XDR portal related to your Kubernetes environment, uh, related to that particular threat, say the threat here within the multi-stage incident, the threat actually here is cryptojacking, and you can also go to the view threat report view, and you can also go through all the related entities that are involved here, and the report details that you can see what are the active incidents, what alerts have been generated here. So this gives you the complete picture of your incident and the threat report, and how this threat can be mitigated. So even a beginner on the containers and knowledge can go through this analyst report and understand what should be the mitigation strategies here. So I hope this is really helpful. So the SOC team can go ahead, pick a particular incident and view the threat analytics report. I think this is a great addition to our container threat mitigation story. I hope this will be very helpful for the SOC teams. So that ends my presentation. So we can open for any Q&A here.
Great. Yeah, thank you. The team has been great with answering questions. We do have a couple worth reiterating. The first one is Defender for Cloud for Docker Hub free?
Yeah, so Docker Hub is included as part of our Defender for Containers plan. So if you are using Docker Hub and integrating your Docker Hub connector into Defender for Cloud, it is free. Docker Hub charges are not free, but the coverage or the security posture management and the Defender for Containers coverage for your Docker Hub is free of cost because it is part of Defender for Containers plan.
Great, thank you. And then the last question we have is, agentless discovery and agentless container vulnerability management are covered in both DCSPM and Defender for Containers. Can we choose DCSPM over container CWP?
Okay, so just to put forward, there are security posture management plan, that is Defender CSPM plan, and the workload protection plan within Defender for Cloud. So the workload protection plans are primarily focused on the real-time threat detection for various workloads like servers, containers, storage, and databases, whereas the DCSPM or Defender CSPM plan is only focused on the security posture management. It is not focused on the real-time threat detection. So for that reason, they need customers need to enable Defender for Containers plan for container threat protection.
Great, thank you so much. That seems to be all the questions we had. So with that, I'd like to thank you, Future and Vasavi, for being our guests and for sharing the great information with our community. Also, thank you to the Q&A team who helped us with answering the questions and providing the resourceful information. To all the listeners still on the line, if you're someone who wishes to aid in the protection of the world from cyber threats and desire to have a say in shaping our strategies, blueprints, and recommendations, then we invite you to become part of our security community. Together, we can make a global impact. So join us at aka.ms/security community. This is also where you'll be notified about the upcoming webinars, events, and other announcements. Also, for those of you who may have additional questions on the topic we just covered or other product-related questions, please feel free to raise them on our Microsoft Tech Community discussion space at aka.ms/MDC community. Thank you all for being part of our community and for joining us on these webinars. We hope to see you next time. Goodbye.